with them. I'm working to find more partners on this concept to try to adapt and apply traditional knowledge in a concept of an interplanetary walkout. Because it's these vehicles over here that are designed to carry 100 people to the asteroids and Mars. It's surprising that these things have been dreamed of for a long time, but we're actually very close to them becoming real. Maybe only in the next 10 years we might see some of these giant vehicles. Elon Musk says that he's going to start doing hopping tests with this vehicle next year, and so so suddenly we're on the verge of a complete transformation where we may be moving into the solar system in ways we hadn't imagined before. And so all of this is prelude and motivation for why we worked on this, defining this challenge to try to get people to start thinking about how they might be involved in space activities. And we, working with partners in Christchurch, NZ, we defined the challenge to focus on Antarctica, to how you can help Antarctic researchers now using space technology, because also Antarctica will be an analog for future Moon and Mars missions. So here's the challenge of driving around in Antarctica, where you may plunge into a hole at any moment. The crevasses are on the ice shelf are often covered just by a little thin coating of snow that makes them very hard to identify. And this is actually from the 1959 Trans-Antarctic Expedition, UK and New Zealand. It's the time when Edmund Hillary went to the South Pole. Somehow they say that they got this vehicle off the crevasse. I don't know how they did it, but I guess sideways maybe. But they also had other people. They had the first New Zealander to die in Antarctica, died on this traverse. But I also like this picture because it was chosen to represent the challenges of exploration and to represent Earth. And it was put on the Voyager record, and it's going outside the solar system right now. But here is our fellow EHF fellow Dan Price, who just returned from a 6-week traverse across the Ross Ice Shelf up here. He's an advisor on this. And here's the path that he took. He was a team of 4 people on these, or actually, yeah, on the vehicles going this traverse. And it was a big traverse. It was bigger than the North Island. You can actually, I'll show you later that how they're avoiding some of the crevasse fields here. But the whole motivation is to go out to set up drilling sites at the boundary of the ice shelf and determine the history of the climate change for the last 1 million years at that site. Here they are planning the traverse. And this is the language that we, with our Antarctic partners, that we came up with for the challenge, for the specific challenge. Using new or current technologies or data in space or on the ice, find the best methods to identify hazards and map a path across the ice, and or design or prototype new sensor systems and algorithms to help vehicles navigate across the ice in Antarctica. And so it's intentionally very broad. We're interested in new ideas on any aspect of this problem. And there's sort of 2 parts. One part is looking from the, using satellite data to identify the crevasses and hazards. And the other part is the sensors that might be on human vehicles or robot vehicles. So we have a lot of different types of skills and capabilities that are related that can apply to this, from the satellite data analysis and mapping information. There's sensors like LiDARs and various other kinds of radio frequency sensors and things like that, flying even drones and robotics. And we're focusing in on this Antarctic navigation challenge, which will then apply immediately to extreme environment applications around in the poles and in the mountainous regions and a variety of other places. We think that there's a direct application to future space applications that are coming very fast. And so in just 5 or 10 years are going to be needed for lunar and Mars operations. And then there's also commercial applications throughout more traditional industries, everything from precision agriculture to forestry and things like that. Some of the aspects of this, there's right now the state of the art is to analyze the remote sensing data over a long period of time, do some person in the loop, hand annotated mapping of crevasse fields. And then this is the path that Dan's team took to, they were coming from this direction and going over here, and they didn't go straight. They had to avoid all these fields, snake their way through, find their way through some crevasses up here, go 50 kilometers out of their way just to avoid some of these gaps there. And while they were driving, they were using these ground penetrating radars out on a boom out front, where if the radar can actually see into the ice and see and identify these crevasses hidden below the ice. And so you have Dan and his team staring at the satellite data here, looking at the the ground penetrating radar here, trying to figure out if they're staying on course with the GPS there. And it's a combination of the worst combination of human factors, because you're just staring at this little screen, and if you see a little vertical line, you have 4 seconds before you plunge to your death. So that goes on for 8 hours. So if you just can't imagine a combination of boredom and terror that's going on for weeks. There's some people have experimented in Greenland with sending little robots out, zigzagging around, trying to map where the crevasses are. With Dan's team, if they found a possibility, they had to go out and poke it with a stick to see how thick it was, if they were thick enough to drive over. Then they were able to fly a drone in some cases, but a lot of times the weather conditions with whiteout, they could not fly a drone. So I don't know if we can design a drone that can find its way back even in the fog like that. So we have judging criteria that are defined in the application area and on our website. This is just a summary with looking for technical feasibility and innovative solutions with factors about ease of implementation and minimizing environmental impact. Team composition is a factor, and people who come up with prototypes or proof of concepts, that's a big step forward. But just ideas and proposed concepts are also welcome. We're collecting resources for people. We have, for example, on the space data analysis, we've been setting up training sessions, and we have training videos and manuals online available just for the satellite data side, and also even some software samples. We're also web links as we collect them that identify different sensors that people have explored. There's summary reports of what's needed for the scientists, because right now these traverses are a limiting factor. It's a major expedition to go to a site, and the scientists, of course, would love to have lots of sites everywhere, but they just can't. Commit to having that many people, doing a traverse for those major efforts. And on our side, we're creating this SpaceBase.co portal for people to create teams and share resources that way. And just got to update this morning to have more functionality.
So let me talk more about the mechanics again of the challenge. So we kicked off the challenge February 1st, and it's going to be open for applications between 10 and April 30th. It's a two-tiered process, so which means that the applicants actually apply in region, and they get evaluated by regional judges in region, so that on May 16th, there's going to be a finalist for that region. So where Wairoa is, it's actually part of the Hawke's Bay, Waitomo, Waikato area. And so by May 16th, we would have a semi-finalist winner for the region. And the finalists from each of the regions, so there's 5 regions, will come to Christchurch during Tech Week, May 24th, to pitch, and then we'll determine the winner of the challenge. So in terms of the applications, it's going to be an online application. There's a portal that you basically go on, and the 2 things that are really the most important here is that you submit a pitch deck, so no more than 20 slides of what you think you're going to be doing, or what's the roadmap of that, and how you're working on the solution. And then the other part is also a short video, a 5-minute video, like if you have a prototype, or you can also talk about in the video what you're essentially doing. The important thing here that I want to really emphasize is that because you can hit submit at the very end, like in April 30, but we really would love for people who are interested to register now, even if you're not fully finished, or you're still just trying to understand what your ideas are, because that's the way that we could be able to give you more information and give you more resources than waiting for at the last minute. For the prize. Again, the grand prize winner is going to have $40,000, and then there's also technical and research support that will be given after by Kalahani Innovations. For the finalists, we're also arranging with the regional partners to have incubators and accelerators give at least 6 months of co-working space and mentorship to the finalist who wins within region. The other thing is that to travel to pitch, one representative of the final team will also be given travel expenses to go to Christchurch in May. And then for all applicants, we're opening up SpaceBase as a community portal that will always be there regardless of whether you apply or not, and give you the resources that is needed to work on the challenge. So Eric's going to talk more about more about the problem itself, but let me end here, at least on the mechanics side, that there's more information on the website, so NZSpaceChallenge.com. And there's an FAQ section there as well if there's questions that you have that we haven't answered. Eric talked about the resources. We have a YouTube channel that has all of the briefing videos, but also all of the training videos as well. There's links and resources on spacebase.co. Again, just for us, our main thing right now is to be able to get the information and the opportunity out to everybody. So if you know of anybody who has not been able to come to the briefing but would be interested, just point them to the website, and you can also find the challenge through our website, which is the spacebase.co. And we thank all of our sponsors that have actually put forward their time and their effort into this. We're really pleasantly surprised about the interest that has been generated, and also the collaboration that has happened. throughout like the regions of New Zealand as well. And for us here, again, Wairoa Council, thank you so much for having us. So I'll turn it back to Eric to talk about more of the challenge itself.
Yeah, one thing also is, not only is Antarctica, New Zealand very interested in any ideas that come out of this, but also New Zealand is headquarters for COMNAP, which is the Committee of Managers of National Antarctic Programs. So 30 countries that have operations in Antarctica are coordinated through the New Zealand office. And so anybody who comes up with ideas that, wants to, whoever proposes solutions, they keep the intellectual property. They can make a business out of it if they want, and they can, and they have an instant exposure to this market that's in Antarctica before you even convert it to something else. So I think I want to show a short video of Dan Price about his recent experience.
I recently last summer took part in the first major traverse that New Zealand has mounted across the Antarctic since Hillary did it in the 1950s. The amount of planning that goes into the traverse is pretty incredible. So it's a 2-year planning phase with the logistics that happens, and then I was involved for about 6 months before using satellite imagery to plan the whole route. Of course, Hillary and all those boys didn't have any of that, so we've got this amazing satellite resource that we can use to get imagery of where we're going and sort of locate all the hazards, and the major hazards are crevasses. So the whole objective is not to drive into one of the crevasses, and these satellites really provide an amazing tool to do it. We also have a radar mounted on the front of the first vehicle, which is an incredible tool because it gives us about a 4 or 5 second warning if the crevasse is coming up ahead of us. So one of us is driving in that vehicle and the other one is continuously monitoring that GPR, ground penetrating radar system, and then we can get a really good idea of what's coming up ahead. All we're trying to do is prove a route so that the science can be done at specific sites, and there is thought in the future that we might use the actual traverse route to do some science too, so drag instruments with us and kind of have a sort of circus of scientific instrumentation on tour in Antarctica.
So I was going to show you just a little bit more about the environment Dan was experiencing there. It's also, to us, it's directly related to Mars traverses. We had, I got the author of the Martian to send Dan some well-wishing for his traverse because it's so similar to what's in that movie. And so, yeah, and very much in line with this, there's if you're traveling around Mars or the Moon, you're making use of satellite data, but there's a whole variety of different kinds of hazards on these environments. And it also is being done right now with the rovers that are operating on Mars. One of our advisors is one of the experts in this. Of course, with the tiny little wheels on the rover, even a big rock is a hazard for this rover. So Dan was operating with, they were hauling tons of material back on these sleds, but with the scout vehicle out front looking for the crevasses. And Alan Gray was also telling us a little bit about trying to operate in Antarctica with just pointing out things like, yes, you can't see geosynchronous satellites, but you can talk with a iridium phone. But he was talking about the frustration of the iridium phone only works outside of your habitat, so you have to step outside. You can't use your gloves to operate the phone. You have to take your glove off at minus 50 degrees, and then the battery dies in 5 minutes. So, so it's you can get one message out through your iridium phone, but they definitely need help in all these areas. One thing that I didn't appreciate as much before, but the humidity in Antarctica is so extremely low that, you know, just sliding going in your socks and going across the carpet, and if you touch the computer, you zap it and fry your computer. And so they, in the computer rooms in the Arctic base, they actually humidify to add humidity to keep the electronics working, so you don't accidentally cause a spark and zap all your electronics. Then the temperature and winds are extreme, of course, and most of these, you know, a lot of these numbers are even in the summer, austral summer, in the daylight. And the dream for the Antarctic scientists is to continue operations even in the Antarctic night, and that's a challenge that these robot vehicles and things like that are just not up to at this point. And so and part of this is just the battery systems are pretty good for what they offer, but even just to charge a battery, you need to warm it up. You can't. There's lots of special things that about power in Antarctica that don't work as you expect. Like, they've been trying for years to get wind turbines that work, and they keep freezing and locking up and not functioning as they're supposed to. And here's the hazards we were talking about with these. If you have a nice thick ice bridge like that, you can probably drive over it, but oftentimes the ice bridge is a meter or less of just a thin crust. And these crevasses plunge down 50 or 70 meters. So there's some of these, we've been talking about the crossing the ice shelf here from the bases of the rocks, the Scott base here and going Dan got over here. But there's certain regions here that they've been trying. They had a team of 60 people that tried for 4 years to get to. They weren't able to get to, and they finally, just because of the problems of the wind-blown snow in this area adds 2 meters every year. So every time they put equipment in, it gets covered up, and they have to start all over again. But all this Antarctica is absolutely critical for understanding for climate change, and this is just Dan's notes on if you melted all of this ice, how much sea level rise you would get. So if you melt the West Antarctic ice sheet, you'd have 5 meters of sea level rise, and this would give you 60 meters. And so, but it looks like they're trying to just monitor how fast the ice sheet is moving up here. And it does look like we might be in for close to a meter of sea level rise by the end of the century. And at the same time, all the melting of the ice and the fresh water that's going into the salt water and drives the circulation of the entire ocean circulation for the whole planet. And so just a slight variation in the sea ice melting can change the circulation that changes the climate of Europe, for example. So this is where they were targeting their drill site that goes through the ice shelf and then samples this mud that has a record of the last 1,000,000 years for climate change. And here's that traverse across the same area that the race to the pole happened. And one problem that the navigation problems, I mean, just in terms of if you don't pay attention and you look down and you look back up, and you may end up be driving, 10 or 20 degrees off the direction that you thought what you were, and you have to, and your GPS takes a few hours to tell you that you're off in the wrong direction, and you could be driving into the crevasse fields that you didn't realize you were going into. So that's that hand-drawn map of the crevasses. This is all satellite data that they analyzed while they were planning their traverse. And if you have a snow cover that slumps and covers the crevasse, you can actually, in a visible image, you can see some stripes here. That's a good indication. But if the snow cover is just completely flat, it's featureless. You don't know that the crevasses are underneath there. And this is a synthetic aperture radar satellite data from the same area that shows the crevasses for that area. And here's this zoomed in of their going from here over there. They ended up avoiding all of this area of crevasses, sneaking through, going in a twisty way through this area, and then avoiding this, going 50 kilometers north, and snaking through, and you can even see them taking a little turn to avoid the twist of the crevasses here, and going up here until it was safe, and then they could go cutting across. And one thing that Dan was describing was, like not being aware exactly, when you're driving, where left or right these hazards are, just because it's a featureless white field. So as you can see, they're hauling all this, everything from fuel to the equipment out there. And this is the ground penetrating radar, right? With the satellite data and the ground penetrating radar and the GPS, and that's the one that, if you see a vertical line, then that's the problem. It's the crevasse coming up, and you have to get out and poke to see which direction the crevasse goes and things like that. So that was, and here's one of their fogged-in days. In a total whiteout, you wouldn't even be able to see that vehicle just a few meters away. And so, so this is the situation and the challenge, and that, and at the same time, we're interested not only in this scale vehicle, but also, robot vehicles, much smaller, or just any kind of capability to go and put equipment out in different places in Antarctica. There's a constant need for this across all these different programs. So I think I'll